Today we are going to learn about the Venn diagrams and the operations on sets. So now coming to the Venn diagrams, they are named after the English person, that is John Venn. And what is the use of these Venn diagrams means, in order to represent the relationship between the sets, they have it will be in the form of a diagrams. We will make use of this Venn diagrams. So in order to represent the relationship between the sets, these Venn diagrams are useful. So how these Venn diagrams will be there means, they will be in the form of a rectangle which indicates the universal set. So, and a closed curves. Usually they will consider the circles. Circle indicates the given sets and rectangle indicates the universal set. So Venn diagrams are the diagrams which are represent in order to represent the relationship between the sets. We will make use of this Venn diagrams. These are generally represented by a rectangle which indicates the universal set, and a closed curve. Usually we will consider it as a circle. Those are the means in order to represent the sets, we will make use of the circles. So whatever the elements in the sets will be written in this inside of the circle. Suppose you take an example. Suppose A equals to A, B, and the universal set is like this: A, B, C, D, E. So how you will represent in the form of a Venn diagram is that you will draw one rectangle which indicates the universal set, and a circle. A circle indicates the set. So here the set is A, so I will be writing it as A. And what are the elements in the set A? They are A and B. So I will write those elements A and B inside of the circle. And what are left other than A and B, what are there in the universal set? It will be written outside of this circle. So what are those? C, D, E. Anywhere in the rectangle and outside of this circle you can write the other elements of the universal set. So this is the rectangle is the universal set. This is how you will represent the given sets relations or relation between the sets in the form of a Venn diagram. Now coming to the operations on sets. So the second part is the operations on sets. In this we are going to learn about the union of sets, intersection of sets, and difference between the sets, and how you will represent the union of any two sets with the help of we will first learn what do you mean by the union of the sets, as well as we will learn how to represent in the form of a Venn diagram and some properties based on the union of sets, intersection, as well as the difference. Now coming to the union of sets. So when we can say that two sets are the union of two sets, what do you mean by the union of two sets? Suppose A and B are any two sets, you think, are any two sets. Then A union B, so A union B will be the set containing both the elements of A and B. It is the set containing both elements of A and B. If any elements are repeating in both A and B, we should write only once. And the union of the sets is denoted by the symbol U. So A union B. This is the symbol for union. A union B. We'll read it as A union B is the set. If I am writing in the set builder form, X such that X belongs to A and or X belongs to B. So it should be, it can be an element of A or it can be an element of B. It contains all the elements of both A and B. So how it is means, suppose you think A equals to 1, 2, 3 and B equals to something like 2, A, B, C. So A union B means it is the set containing all the elements of both A and B. So I am writing here 1, 2, 3. These are the elements of A. Now coming to B, 2 is there. So 2 already we wrote. We no need to repeat it again. So the remaining elements are A, B, C. So this is how we should find out what is the union of two sets. So union of two sets is nothing but the set of all the elements of both A and B. If any element is repeating, we no need to write it twice. We should not write. Okay. Now, how we will represent this A union B by Venn diagram, let us say. So you will draw a rectangle to represent the universal set, and here two sets are there. So we will draw the two circles like this, A, B. So A union B means it is the set containing all the elements of A and B. So like this we will represent A union B. So what is the set builder form of A union B? A union B equals to X such that either X is an element of A or X is an element of B. That means it contains all the elements of both A and B. Now coming to properties of union. First one, commutative property. So these all we have learnt in our lower classes. This commutative law you can say. So that is A union B equals to B union A. That means commutative union is the operation union is commutative. So A union B equals to B union A. Second one, associative property, that is A union B union C equals to A. You take any of the sets, they are going to satisfy all these properties. It holds commutative property, it holds associative property and identity property. A union phi means the empty set. If you are going to get A, then it is called the law of identity, and phi is called the identity of union, and phi is called the identity of union. Now coming to the fourth law, idempotent law, that is A union A equals to A. Then we are going to say that law is the idempotent law. And next one is the law of universal set. Universal set union A. If I do the union of the universal set and any set, I am going to get again the universal set. So this is the law of universal set. Now coming to, so what are the properties of the union? It holds under the the union will hold the commutative property, that is A union B equal to B union A. You take any sets for a example, A equals to anything A, B, C, D, like that. B equals to 1, 2, 3, 4. A union B you do, you are going to get the same elements. Whatever you are going to get for B union A. So therefore it holds commutative property, as well as it holds the associative property too. That is A union B union C equals to A union B union C. The next one is the identity law. Law of identity, you will be saying if any set is the union with the null set, you are going to get the same set. The null set or the void set or the empty set is called the identity of this union. Next, coming to the idempotent law. So if union is operated on the same set, then you are going to get the same set. That is A union A equals to A. Then we say that idempotent law holds. So it is holding commutative property, associative property, identity property, idempotent law, and the last one is the universal law. That is universal set union, any set you will be getting the universal set itself. Now coming to the intersection of sets. Intersection of sets. Intersection of sets means if I take A and B as any two sets you think, then in A intersection B is denoted by A intersection B. This is the symbol for intersection. It is the set containing the common elements of both A and B. So which are common in both A and B, only those elements will be coming in this set. So common to both A and B. So which are common to both A and B, so those elements, it will form a set that is called as the intersection of the set. That means suppose A equals to 1, 2, 3 and B equals to 2, 6, 7. So A intersection B means which are common in both A and B, only those elements will be coming in this set. Like see here, which element is common in both A and B? Only 2 is common. So you are going to get 2 in the intersection. That is A intersection B is 2. If no element is common, so it will be the null set, no element. Now how you will represent this in the set builder form is A intersection B equals to X such that X belongs to both A and X belongs to B. X should be an element of both A and B. Then only I can say that that element is present in their intersection. Otherwise, it does not hold. So now coming to the Venn diagram, how you will represent the Venn diagram of this intersection means. So first we will draw a rectangle to represent the universal set, and here two sets are there. So we will draw two circles A and B, and intersection means we will write all those elements and which are common for both A and B, that will be written here. Like for example, if I take this 1, 3, the other one is 6, 7. So which is common? That 2 will be written in this part. So this is the intersection part. We will represent the Venn diagram like this. The shaded part will gives you the intersection of both the sets A and B. So how we read regarding the union of the sets, all those properties, in the same way regarding the intersection also there are some properties. So the first property is the commutative property. It holds the commutative property, that is A intersection B equal to B intersection A. Similarly, it holds, second one is the associative property. A intersection B intersection C equals to A intersection B intersection C. Next comes the idempotent law. So that is, the third one is that law of empty set, that is phi intersection A equals to, means if any set is intersected with the null set, you are going to get the null set itself. If you do the union, you are going to get the set. If you do the intersection, you are going to get the null set. Next one is the universal set. Universal set intersection A equals to A itself, because universal set contain all the elements what A is containing. If I do the intersection, both in both the sets, the elements of A will be common. So you will be getting like this. Now idempotent law, that is A intersection A equals to A. And now coming to the distributive law, that is A intersection, it is based on both union and the intersection. A intersection B union C equals to A intersection B union A intersection C. So these are the properties based on the intersection. Now coming to the third one, that is difference between the sets. Difference between the sets. So if A and B are any two sets, you think, if A, B are any two sets, then A minus B means it is the set containing the elements of A which are, means the elements of A which are not in B. So what is that? X such that X belongs to A and X should not be an element of B. Such elements will be there in this set. Like suppose if A equals to 1, 2, 4, 6, you think, and B equals to 2, 5, 6, 7, 8. So A minus B means the elements of A which are not in B. So 1 is there here, but 1 is not there. So we will write 4 is there, 4 is not here in this set. So 1, 4. We should not write 5, 7, 8 and all this. So what do you mean by the difference of this set? The elements of A minus B means the elements of A which are not in B. We should consider only those elements. Suppose B minus A means the elements of B which are not in A. So 2 is there, 5 is not there. I will be writing 5. So 7 is not there. I will be writing 7. 8 is not there. So like that. Elements of B which are not in A. So this is about the difference between the sets. Now coming to in the intersection, we had seen that A intersection B means X such that X belongs to both A and, means A and X belongs to B. Suppose if there is no common element in both A and B, you think, then you are going to get a empty set. Like, you think like this. A equals to AB, B equals to 3, 4. So A intersection B means it should contain the set should contain both means the elements which are common in both A and B. Here if you observe, there is no such element which is common in both A and B. So that means it is a null set. So if A and B are not having any element in common, then such sets are called as disjoint sets. Disjoint sets. So in the next class we will do some problems related to this.